Thank you, and welcome again to an amazing session of the Young Voices of Pathology webinar series here at SigTuple. I'm Dr. Renu, hosting this for you today. Before we even talk about our speaker, a little bit about why we plan to have a session like this. While it's always great to listen to expert opinions and listen to people who come with a lot of experience, we wanted to kickstart this new year by giving an opportunity for young pathologists to come out there and voice their opinions and perspectives, especially with the evolving landscape of digital and technology, the fast-pacing world in which we're trying to balance and adapt a lot of new advancements which are coming up in our way. There is confusion, there is hesitation, there's probably even intrigue and curiosity, or is there a certain amount of comfort that we are feeling today, to adopt certain things in our practice. And what better but to hear from our young speakers today who seem to be the very fray of things, and they seem to be adopting things at a very fast speed than what we did, at their times. And I have been associating with these young speakers in different platforms and forums, especially in conferences. And I've been so intrigued with the way their mindset is and the curiosity of seeing what they can possibly do to deliver in such spaces. So with all of that thought, we came up with this Young Voices of Pathology, and we're very happy we did that in the previous session. And today also we have a very intriguing, excellent speaker amidst us, for whom I will be giving a short introduction. Followed by the introduction, there will also be a small quiz that we are going to start with before the actual talk. So sit right there and enjoy this session today. So our guest speaker, folks, is Dr. Mayank Plaha, and the topic of today's webinar, which will be delivered by him, is the future of hematology, where morphology meets artificial intelligence. A little bit of Dr. Mayank, Young Voices of Pathology SigTuple webinar series. He is a pathology resident from the Armed Forces of Medical College, Pune. His academic interests are hematopathology, digital pathology, AI-based diagnostic solutions, and also he's involved in ongoing research in AI-assisted peripheral smear and cytology analysis. A very dynamic person. You'll find him very creative in his talk as well, and very intelligent as well. I had a lot of fun discussing various topics with him when I met him in the last conference, and I thought we should have him here on our platform to see how well he could associate with all of you. And I hope that you will find today's session really interesting. But before we actually go on to our speaker, there is going to be a small quiz. The first two correct answers obviously get a prize from SigTuple, on behalf of SigTuple. I want you to identify just two abnormal cells in the two pictures that I'm going to be showing it to you today. Just put it up into the chat box. And if you had already registered for this webinar today, we would obviously have your contact address. But if you have not registered and you still want to give your answers, do leave your email contact there, so Mr. Manohar Daka from our team will be able to reach out to you. So in a count of 1, 2, and 3, here we go. This is the quiz question. Identify two abnormal cells in the following picture. There you go, guys. Identify two abnormal cells that you're seeing. This is RBC, that's the clue. And put it up in the chat box. Encouraging all the participants to go through it. Any of the two abnormal cells that you're seeing in this particular picture. Go ahead, take your shot. Daka, is the time good for us to declare?
Yes, ma'am. Yeah.
All right. So these are sickles and target cells. Definitely the two abnormal cells. So these are sickle cells, very easy to identify, right? It's overall, you can see a lot of anisopoikilocytosis in the picture out over here. And what are these cells? What does this remind you of? Have you ever played the dartboard where you want to put something onto the target? Isn't it like bingo, right? So this is your target, right? This is a target cell. So sickles and targets is the right answer. And there we go. Dr. Induputran gets this answer right. And okay, then Howell Jolly bodies, we're not talking about that, but definitely target cells again. Micronuclei, probably microcytes. Is that what you are referring to? So yes, there are some microcytic hypochromic cells out over here. The right answer was sickle and target. So yes, we will give the first two participants the winning answer for this particular quiz round. And yes, I hope that helped to break the ice and got you all in a very comfortable, casual position, because that's what we expect in this webinar. There's nothing like a formal attitude that we want you all to have. It's learning, it's fun, it's about exchanging dialogues, exchanging feedback, suggestions, anything. We're all here to learn from each other. So with that, I will now hand over to our speaker today, Dr. Mayank Plaha from AFMC Pune. Over to you, Dr. Mayank, and thank you so much again. And I welcome you again on behalf of SigTuple for being with us today and having this webinar with us. Thank you.
A very good evening, ladies and gentlemen. Thank you so much, Dr. Renu, for that amazing introduction. I am really humbled by your words. I hope I'll be able to do justice with my presentation. So I'll just try to start my presentation. Ma'am, I hope the presentation is visible.
Yes, crystal clear.
Right. So a very good evening once again. So when I was given this opportunity to speak on this topic, to try to share my opinions, my understanding of what hematology today is and what automation, digital hematology, and artificial intelligence can do to hematology, I was really intrigued, and I was really looking forward to sharing my views with you all. So I'll just like to start with the topic. So just try to make you understand what the topic is. So the future of hematology, where morphology meets artificial intelligence. Hematology today is mainly based on morphology. We see slides, we see peripheral blood smears, we see bone marrow aspirate, we see bone marrow biopsy, and try to form a diagnosis on the basis of that. It is the volumes of the slides we receive is increasing over the past few years, and everything is evidence based now. Clinicians want to send everything to us and get our opinion on the basis of the morphology that we see in various slides. But something very interesting is meeting the morphology that we are seeing, and that is artificial intelligence. Artificial intelligence has started to recognize patterns, has started to understand various cells in a way that even we cannot, or we face difficulty in. The amount of quantitative analysis artificial intelligence can do, and with good speed and precision, we sometimes fail to. However, we have to understand that even though artificial intelligence has started and to analyze patterns, started to detect cells that we have not been able to, the pathologist remains central in the diagnosis of any hematological disease and will remain to do so in the coming years. What artificial intelligence will help us to do is just make our work more efficient, help us to give more informed decisions, and just improve the overall functioning of how we work. So with this, I'll just start my presentation. So changing landscapes of hematology. I'll try to tell you how hematology is evolving now and how the time have changed, how things have become more evidence-based. So everybody here would be aware that the volume of complete blood counts, the CBC count, has been increasing over the years. And for any case, the clinician, this is probably the first investigation a clinician gives. So there is a tremendous rise in CBC volumes in any center, maybe small, maybe large. And me being, I'm in the past 1 year of my experience in pathology, I have seen a tremendous rise even in these past few months. However, peripheral blood smear still remains a very important investigation for the clinicians, and they want to know how the blood smear looks like to a pathologist on a smear. So they do rely on the complete blood count reports that they get. However, still they want to know that how these RBCs, how these WBCs, how these platelets look like on a peripheral blood smear. However, with this, there is something that we need to understand about peripheral blood smears. We as pathologists know this and we have faced this. There is tremendous amount of inter-observer variability while assessing, while reporting peripheral blood smears. Two pathologists, maybe even working in the same center, do not find a cell similar. One may call it a lymphocyte, one may call it an atypical lymphocyte, and the third person may say that this has reached a level where I can call it a blast. So there is inter-observer variability due to how we are taught, how our understanding has developed, and on the basis of that, the reporting we do for peripheral blood smears varies. The turnaround time, the expectation for turnaround time of peripheral blood smears is decreasing day by day. So maybe a few years ago, it would have taken a day to report, but now, as soon as the blood reaches the lab, the clinician expects that the report should be out in another 30 minutes, maybe. So expectations have become unrealistic, and we have to meet them. We don't have an option, but we have to meet them. So the turnaround time is decreasing day by day. And all of us do agree that there is shortage of pathologists in big centers, in small centers, and that is directly affecting the workload on the pathologists that are available and is somehow affecting their efficiency. So maybe in the morning you have to see 400 peripheral blood smears in a day. You will start with your full energy, with full zeal, and with a fresh mind, maybe for the first 100, for the first 200. But towards the end, all of us being pathologists would agree that a fatigue sets in. We have that mental block, and towards the end, it becomes difficult for us to concentrate and to actually do justice to the peripheral blood smears that we are seeing. And everybody would have faced this. And this is something that we need to understand and we need to accept that we as a human, we have limitations. So we cannot be the same seeing the first PBS of the day and maybe the 400th PBS of the day. So what is digital hematology? How digital hematology is coming up and what exactly it is? So we need to understand that the peripheral blood smears that we make on our slides need to be automated using various whole slide scanners. There are different companies, various models, with various specifications that have come up, and numerous options are available in the market. So the process of digital hematology starts by making these slides digital. Now, this is the first step, but probably the most overlooked step. We very comfortably overlook this step and we take it for granted. But we need to understand that in a resource limited setting like ours, this probably is the most important step and forms the bottleneck of this entire workflow. Till the time the slides become digital, nothing in the workflow becomes digital. So neither we have telepathology or so-called telehematology in place, and neither we have all the AI models that are coming up, either paid or we are creating our own AI models to see how these cells are looking like in a peripheral blood smear. So understanding that how important digitizing these slides is and how important a scanner is to make sure that the digital form of these slides that we have is of good quality to view on our screens to form a report and to subsequently use various AI models on it to detect cells and to make clinical decisions using. So we need to have good digital scanners to form good digital copies, to form good whole slide images of these slides. Once these whole slide images are formed, once we have been able to digitize these slides, the next step is proper storage of these slides. Now, it can either be a network attached storage that we can have on our own, in our own center. We can buy one and we can use it for our own storage and access it whenever we want to. Or we can use the cloud-based services provided like the Amazon services or the Microsoft services and numerous others available in the market suiting our needs and our specifications. But we need to have storage devices because the whole slide images that are generated are huge. They occupy a very large digital space reaching into gigabytes. So good storage is absolutely important if we are planning to create a digital atmosphere, a digital ecosystem in our hematology practice. So the next thing that comes is these artificial intelligence algorithms, these models that are coming up and are able to recognize the cells in these whole slide images, give a percentage, flag them, and help us understand them and quantify them in a way that probably is not possible for a human. For example, we on a peripheral blood smear doing a DLC, we just count 100 cells. Now imagine an AI algorithm working on a whole slide image, counting all the cells possible on that particular slide, counting all the neutrophils, and then giving a differential percentage. This is like what a Coulter does, a complete blood count does, but on the basis of morphology. So that what AI can give us. And this is just the beginning. This is just a very basic level of understanding that the AI has, but many new things will come up, and this is the next step. And finally, what we have to do, what we need to do using these digital images is creating an ecosystem of telehematology or telepathology in general, where any slide that is maybe scanned in a peripheral center, a tier 2, tier 3 city, or a primary health center in any village, with the help of good whole slide scanners, can be seen by a pathologist sitting remotely in a big city and can give out the report, greatly enhancing, greatly hastening the overall clinical process. So telehematology is something that needs to come up, is coming up, and we as pathologists should try to create the ecosystem for the development of this telehematology. So with this brief introduction, just I will briefly revise what I just told in the introduction part. I think one takeaway point which I want you to understand from the introduction part is the most important step of digital hematology is the initial part where the slides are being scanned. That is the bottleneck that forms the most important part and cannot be ignored. Next, I'll be briefly discussing about the technical foundations of digital hematology and the artificial intelligence per se. So how do these slide scanners work? As I've already told, the most important step. So what do they do in a very I would say a layman language and not something not getting into something very technical. So these scanners are nothing but a microscope which takes multiple images of the entire slide, a very high resolution optical imaging of the entire slide. So multiple images are taken of the entire slide. A field by field scanning is done either at 20x, 40x, or some scanners are even providing 100x scanning now. So different multiple images are taken. All these images are then stitched together to create a whole slide image. Also, a feature that is added in these scanners is a focus stacking, or the Z stack, which any of us who are interested in digital pathology would be knowing. So these images are taken at different levels, keeping in mind the thickness of the smears, the thickness of the slides, and different artifacts that come up while preparation of these slides, which are very, very common in our Indian setting. Because even though how much we try, it is very difficult for us to standardize our staining, to standardize our peripheral blood smear thickness. So Z stacking forms a very important part of the scanners. And whenever we are investing in any whole slide scanner, we should absolutely understand the Z stacking capability of that scanner. And finally, the output is the whole slide image, which is a navigable digital slide which can be accessed using any image management system and can then be either viewed or can then be used to apply any artificial intelligence model. So just briefly on what are the basics of artificial intelligence and morphology, how do these AI models work? So there is an input image. So on your left side, on the leftmost image is of a neutrophil probably. It's a cell image. So what does this AI model recognize? So we need to understand that though we call it as intelligence, the AI model will not take into account any context of the slide. Like, for example, they will not understand that we are trying to look for neutrophils in a case of sepsis or something like that, but they will just understand that there are certain patterns, there are certain colors, there is certain morphology associated with this particular image, and create feature maps, various maps like a circle or different colors. On the basis of this feature extraction, the model understands that this is a particular cell, which we have already trained the model to know, which I'll be discussing subsequently on how these models are trained and how important the data that we use in training is. So the image is there, it extracts certain features. On the basis of that, it classifies these cells, and finally an output is given. Now the word which is very important here, is it is a probability output. It only gives a probability that this particular cell, which the model is seeing on the basis of all the feature maps, there is a very high probability that this is a neutrophil. It cannot be sure. And this is, I feel, is how we also work. Whenever we see a cell, we, on the basis of all our years of expertise, our understanding, and what we know, we in our mind create a probability that this is most probably a neutrophil. Now, over the years of our understanding and learning, the probability reaches very close to 100% for our basic cells like neutrophils, but remains dicey around 60, 70, 80% for some complicated cells like blasts. So even this is the same case even for an artificial intelligence model. It gives the results in probability that this, according to it, is 82% probable to be a neutrophil. And this is how all these models work. So the next thing that
We have a
do
question
is,
in the chat, Dr. Mayank. We have a
yes,
question
ma'am.
by Badrinath Durayrajan. Is there any staining-induced dependence for the morphology classification with the networks?
Staining induced dependence is absolutely there, ma'am. So I'll be talking about it subsequently,
Sure.
that how important these slide scanners are and how important the pre-analytical variables are in making digital hematology actually useful for us. I'll be discussing it subsequently, and if I'm not able to answer this question, I'll be very happy to answer that. I think maybe at the end of the
Sure.
presentation, if that is okay.
That's fine. Please carry on.
So just a brief on what AI does in terms of this. So a more complicated diagram of these convoluted neural networks that are there. So there is a basic image, feature extraction is done, all these features come together, different layers are created, and according to these features, on the basis of the training that the model already has, it classifies this cell to a particular cell and gives a probability of how much probable this cell is to be a particular cell that we want it to understand. So what AI sees versus what pathologists see. So all of us have this fear, dilemma that AI might take over our work, AI might replace pathologists. Over the last 1 year, the brief time I've spent in pathology, and I have been able to understand this process of digital pathology and AI in pathology, I can assure you on my part that this is not going to happen for the next 10, 15 years, because AI just recognizes patterns. It can tell you that this cell is of a particular pattern on the basis of data that we have already given. But a pathologist, knowingly, unknowingly, subconsciously, takes in many different factors while analyzing a particular slide. We may not do it consciously, but over the years of our training, things come to us subconsciously that this particular cell, if I'm seeing this cell, you might have a particular memory associated with it, or you might remember something which you have read or which you have interpreted over the years. And we take into account a different biological context while seeing a slide, which AI unfortunately is not able to do extensively right now, but there are different models coming up, and they are saying that it might be able to in the coming years once we are able to make it understand the context. But as of now, it just recognizes patterns, tries to correlate patterns with the knowledge it has, and then give out an interpretation, unlike humans, which take into account various biological parameters, the clinical input, the overall experience, and then give a final answer. So I've talked so much about these AI models and how fancy they can be, how they can do our work, they can be very efficient in detecting cells, they can make our work more efficient. But the most important step in creating these AI models is the data. The data requirements for training these AI models is the backbone of any AI model. The AI model may look very fancy. It may detect some cells which even a human is not able to, but you will realize that the model is as good as its training data set. So for any of you who are trying to create their own AI models for anything, for hematology or pathology or any for histopathology or cytology, you should be very meticulous with the data you choose. You should be very meticulous with the annotations that you do. So I'm very sure that all of you know what an annotation is, but just briefly, if somebody is not aware, annotation is nothing but labeling a particular cell and making the AI model understand that this particular cell is a neutrophil. So I take an AI model like a small baby who has just started going to school. So you start training that baby. So you hold the hand of that baby and tell that this particular cell is a neutrophil, this particular cell is a basophil, then an eosinophil. And on the basis of this training, over 1,000, 20,000, 40,000 images, the model becomes comfortable in then detecting a neutrophil. So it is as good as the training it receives. It is as good as the annotation that you do while training these models. So very important to annotate them properly. Also, we should be very careful in not having a biased data. With the biased data, I mean that teaching an AI model about blasts on 100 cases of acute lymphoblastic leukemia is not the right way to do it, because we are creating a bias by just showing it the blasts and not showing it that what a normal cell looks like. So the data has to be mixed. We have to show it cases of ALL, we have to show it cases of reactive lymphocytosis, and how a blast may look very similar to a reactive lymphocyte, but is very different from a reactive lymphocyte. So that understanding an AI model will get only if our data set is very diversified and properly annotated. So that bias introduced by staining, scanner, and populations is not there. So the question that we just had is, do these AI models have a problem in stain by assessing anything on the basis of stain? Absolutely. Stain variability will come because the training that we have done is on a very uniform type of staining. So that is why a single centric model that has been created will always have a bias towards a particular type of staining. For example, I am creating an AI model in my particular institute. There is a particular level of uh, Leishman staining that I do for my peripheral blood smears, and it is pretty same over maybe an entire year, because my technicians are same, the way I make my stain is same, the way I perform the procedure is same. However, if that particular AI model is expected to detect any cell in some other institute, it might not work as good as it is supposed to, because the staining intensity will be different, the staining variability will be there, the stain might be different. So staining standardization is very important while training, but we need to accept that we cannot do that in our country. No matter how much we try to make the stains absolutely standard, we are not able to. So we need to train our AI models on a variety of staining. For example, I can take few peripheral blood smears from my center, few peripheral blood smears from a different center where the staining is completely different. So it is like giving a rigorous training to the model, so that no matter what type of staining you give, it is able to detect the cell even then, because you have already trained it to detect to that particular thing. Different scanners. So there is a bias for a particular scanner. You have scanned with a particular scanner, it will be different. Another scanner, the image will be different. And models created on maybe one particular scanner will not able to detect cells of whole slide images on a particular different scanner. So again, the what comes into place is we need to have staining variability while teaching, and we need to have different scanners while teaching. So by a brief understanding of what hematology has moved from morphology to artificial intelligence, digital hematology, how these AI models work, how digitization works, a brief explanation of what are the probable clinical applications of digital hematology and artificial intelligence. So something as simple as RBC morphology. AI has strengths in detecting something and has pitfalls in detecting something. So the strengths, it is very accurate in detecting the size, which a human eye will miss, because we will not be able to differentiate between an 8.1 micrometer RBC and a 7.8 micrometer RBC. Our eye, with its capability, will take them to be of the same size. Artificial intelligence, on the other hand, will be able to differentiate these sizes. Shapes, AI will be very good in differentiating the shapes, which we will not be able to. And quantitative trends in the form of, are the shapes uniform over the last 5 days? Is the size of the RBC changing over the last 5 days? our eyes might miss, but AI won't if it has been trained properly. Pitfalls: the AI model with mixed populations. For example, there are macrocytic, microcytic, there is severe anisopoikilocytosis. An AI model, if not trained properly, might be facing a lot of difficulty in detecting the RBCs there. And any subtle poikilocytosis and any overlapping artifacts, for example, any stain artifacts, any stain deposits that have come there, if not trained properly for those stain deposits during our initial training, the model will face difficulty in final detection. Next, the WBC morphology. This is where I feel AI is actually doing very well, because the pattern recognition, AI has mastered the pattern recognition for WBCs. So it is able to do an accurate classification of mature WBCs. Differential count consistency is very high. We as humans in a peripheral blood smear, maybe today I see a particular set of 100 WBCs and give a DLC. Tomorrow I see a different set of 100 cells and give a DLC. So there will be variability even when I am seeing the same slide 2 times. This is not the case with AI, because it sees all the cells available on a whole slide image and then gives a DLC. Flagging abnormal populations, very easy for AI, because it is able to map the entire slide and see all the cells at once, which we face difficulty in because we have a shortcoming in scanning the entire slide. We take time. It is difficult for us to scan the entire slide, and we might miss those 1, 2, or 3, 4 blasts present, which an AI can detect very easily. And AI is very good in screening large volumes, which, as I have already told initially, we will face difficulty because that is a human constraint. We cannot be as good as we are in the first PBS we are seeing and the 100th PBS we are seeing. So where AI fails in detecting WBCs, reactive versus non-reactive lymphocytes, this I am very sure even I have not been able to understand after my 1 year of pathology, and even AI faces difficulty detecting these. Next, early blasts. So difference between a blast which has not yet become a blast, but there are certain features which are not good in the cell. Dysplastic neutrophils, AI might detect it as something completely different altogether. But if we have trained the model properly, it will be able to detect even these. Next, the platelets. This probably is most difficult for AI to detect, understand, and give a final probability, because platelet clumps. So very difficult to understand, is usually misclassified by various AI models. Size variation, giant platelets, if not, the model is not trained properly for detecting these might be detected as RBCs. As we already know, even our day-to-day Coulter machines that we have, the CBC machines, even these detect these giant platelets as microcytic RBCs, and we can see that the counts get swayed on the basis of that. So we need to understand the model has to be trained to detect these specific giant platelets as platelets and not smaller RBCs. And other features like satellitism or quantification errors, which is difficult for the model to do on platelets, because very difficult for us to train the model to differentiate between stain deposits and platelets, which we as pathologists do on the basis of how refractile that particular structure is, and then take a call whether that is a platelet or just a stain deposit. Hemoparasite detection, again, there are limits because it only works well at high parasitemia, misses low-level infection, and many artifacts mimic parasites. Even we face difficulties. A small gauze piece thread on a slide, we might think of it initially as a particular hemoparasite, but later on, by making sure that it is refractile or not refractile, we come to a conclusion that this is just a small thread and not a hemoparasite. Currently difficult for AI to detect. So a brief on some case examples on AI versus human, how we can come together and finally give an output. A normal smear, very easy for AI to pick up, and we can reduce the time we spend on a normal smear. Reactive lymphocytosis, AI flags, and we can confirm any suspected blasts. Again, AI will flag that this particular PBS is not okay, and we can spend our energy and time on these particular peripheral blood smears and less on those which AI has flagged as normal. Though we may find something abnormal even then, but AI can act as a tool that can triage our peripheral blood smears for us. For example, if we have 200 peripheral blood smears, it can triage that these 20 need your attention because there are certain atypical lymphocytes, there is some mixed RBC morphology or some suspected blasts which need your attention, your energy and your time more than other peripheral blood smears. So this will not only improve our efficiency, but will also help us take out better reports. So how does this workflow happens? What is the importance of QC? What are the pre-analytical variables? And finally, how do we validate these? So pre-analytical variables, most important thing in digital hematology, in artificial intelligence, in hematology is the pre-analytical variables, because we have a wide variety of variation in how the smears are made, how there are artifacts created while drying. The stain quality is different, the consistency, the time that we spend, the sample age, maybe the sample is 1 day old and the smear formed is completely different. So the pre-analytical variables, the more we are able to standardize and reduce these pre-analytical variables like stain quality or the smear formation, the better the digital hematology will be, we will be able to have, and the better models we'll be able to create and train, and the better the models will perform. So it all starts with the pre-analytical variables. However, the analytical variables, that is how the scanners scan these slides, what are the focusing errors, the illumination inconsistencies, and the final segmentation or the final stitching together of these images happen. So our entire pre-analytical workflow will be very good. We have meticulously made sure that every step is followed properly. However, if the scanner is not calibrated, there will be problems. So we need to make sure that our scanners are working properly, the softwares are updated, the focusing is okay, the illumination is okay, and only then we can go for it. Validation strategy, how these AI models can be validated once created. So we need to compare them with expert consensus. There can be, if there is any discrepancy in the report, there can be a consensus between 2-3 pathologists, and only then we need to make sure, we need to understand whether an AI model is performing as per the expert consensus, sensitivity and specificity benchmarks. Now, these presently are very vague. So we need to have specific, while validating these models, we need to be very sure that what is the gold standard that we are following, and we need to have certain benchmarks created for these AI models, and only then we can use them. Secondly, define acceptable discordance, that we maybe an AI model is flagging something as an abnormal lymphocyte, but we are calling it as a blast. So how much discordance margin can be there between us and the model? We have to make sure. Secondly, subgroup analysis. Different subgroups, how do we understand them and how the model understands them? QC, the quality control, just like any our routine hematology practice, has to be rigidly followed. Once we switch to digital hematology and AI in hematology, there need to be mandatory review categories, that anything that AI flags as blasts or atypical lymphocytes or platelet counts or anything overlapping, that has to be reviewed by a pathologist. There has to be a defined review percentage, that a percentage of cases will be reviewed once seen by a pathologist. There has to be a mechanism for escalation for critical flags, and there has to be proper documentation and audit trails. So maybe after 4, 5, 6 years, if we have to check that how things have happened in a particular lab over the past few years, there has to be proper trails that have to be left. And how we can actually use these use this digital hematology and artificial intelligence in our day-to-day functioning, this needs to be integrated with our LIS. So how can this happen? We start with basic CBC testing. A Coulter tests a particular sample, gives its report. Second step, the AI model that we have created scans these slides, does a triage for us, and flags those particular slides that need our attention more than others. A pathologist will review these slides, a proper remote reporting is done, and finally the report is taken out after following the regulatory compliance and after actually having a traceability for these images. So after understanding that what hematology is today, how these AI models work, how these AI models can be trained, the importance of good data, the importance of good whole slide image scanners, the pre-analytical variables that can hamper our hematology workflow. Finally, what is the future and how can we move from morphology to artificial intelligence in hematology? Future of hematology automation might sound fiction right now, but trust me, this is something that we will be seeing in the coming future. Robotics assisted smear preparation, it has already been started, already been being tested in certain labs. A lot to be done, but once started, all the pre-analytical variables of how the smears are being made, how the scanning is being, how the staining is being done, will be standardized, and it will be very easy for them to digitize these slides. Followed by real-time AI triage, as I've already explained, AI does a triage for us, and then we review those slides. Finally, the report is taken out. So this is how a fully digital hematology lab will look like, maybe in the coming 5-10 years. But another point, once again, a point I want to reiterate, AI will just assist us. AI will help us, help our lab to become more efficient, help our lab to perform better, and will be a boon for us in our day-to-day reporting. Another very important concept, which I want to reiterate again and again, and this is something that we actually require for our country. Digital hematology will play a greater role in telehematology and subsequently in AI. But we need to focus on creating these telehematology networks for smaller tier 2, tier 3 cities, and for that matter, even our villages. So under the Anemia Mukt Bharat program, we can have the peripheral centers, like the peripheral healthcare centers or the sub centers, have the peripheral blood smears prepared. These smears can be digitized, and pathologists sitting in the tier 1 cities or in big hospitals or in big medical colleges can review the slides which have been flagged by AI or by some other technician, maybe in the periphery, and we can give a structured report sitting somewhere remotely. This will help us in making our clinical decisions better and faster. So telehematology is something that will come up, and we should contribute in making this to come up for the creation of an overall ecosystem of telepathology in our country. How trainees should prepare? So just a small I can say what I have seen over the last 1 year and how I see it. The most important thing for a trainee, even in the era of digital and AI, is to master the basic fundamentals of morphology. So if we have this, if we any of the trainees in pathology have this idea that why should I learn how a neutrophil looks like or how a blast looks like? An AI model will take over and it will detect it for me. No, that won't happen. That cannot happen, and that shouldn't happen because there are medical legal implications associated with it. As I've already told, the model is as good as the training you give to the model. It is as good as the data set used for the training. So relying on a model completely for detecting certain cells in your peripheral blood smear, it is not possible, will not be possible for the next 5-10 years. So we need to master the morphology fundamentals, just like our seniors have done over the last 10-20 years. We as pathology trainees need to understand the strengths and limitations of artificial intelligence. But before that, we need to understand what digital pathology is, completely understand what is the workflow of this, and we need to participate in data annotation. More and more, we need to annotate slides because that will not only help us become better pathologists, but will also help us create better models. So spending time in data annotation over the coming years is what is required for our country to create our own good AI models created by data on our own population. So right now, all the available AI models, most of the available AI models, very few of them have been created by using our data, by Indian data. And we very comfortably are using those AI models created on some foreign data and we are trying to make it detect certain cells in our slides. So that cannot be the case. We need to create good AI models using our own data, which has been annotated properly. And this is where a trainee, a pathologist, a budding pathologist will play a role, because we will be there for the next 5-10 years. So what we learn now, how we develop this habit of proper annotation now, is what we'll carry forward over the next 10 years. And the most important thing, we need to embrace that quality control is important, and we need to make sure that the pre-analytical, analytical, and all these factors are taken care of if we have to create a digital or an AI ecosystem in our surroundings. So just to summarize of what I have talked about over the last 40 odd minutes, digital hematology is inevitable. So if somebody feels that, no, I don't need to know digital hematology, don't need to understand digital hematology, I don't need to understand artificial intelligence, it is inevitable. It will come. You want to learn about it, good. If you don't want to learn about it, it is your loss, because the future is very grim for pathologists who are not conversant with digital pathology and not conversant with these artificial intelligence models that are coming. So, as I had read somewhere, it's a very good line that I follow. Artificial intelligence will not replace pathologists, but the pathologists who understand artificial intelligence and are using it, those pathologists will replace the other pathologists. So, with that note, the pathologist remains central. That we have to understand, that we have to accept, but we need to understand that we need to be conversant with the digital part, we need to conversant with the AI part, and future only belongs to hybrid expertise. Future belongs to the pathologists who are conversant with digital pathology, who are conversant with artificial intelligence and pathology, and this is how we should go ahead. Thank you so much. I hope I was able to clarify the concepts I tried to. Now, if there are any questions, I would love to take something that I have not been able to cover in my presentation. I'll try to answer your questions.
Thank you, Dr. Mayank. That was very incredible presentation. The clarity of thought, the commitment behind the effort that went in actually creating a PowerPoint with your thoughts and perspectives behind it. And that too being hardly a year old in your department means a lot of diligence and effort from your side. And we definitely appreciate it. A good round of applause to you. And I'm sure the audience present here today will second me on that. I myself was quite baffled with the way of your thought process, especially when you highlighted things about pre-analytical, not just in digital, but even in manual microscopy.
Yes,
It's so important that we start our day, in fact, right? Like we look at the staining quality, the smearing quality, and then comes even on manual microscopy, and all that becomes tenfold times much more important when you're talking about digital practice today. So pre-analytical, and then how you went on to analytical, and then post-analytical, and not to mention the QC. QC protocols are very important even when you follow digital practice. How you validate, how do you affirm that validation, how do you conclude those validations, and see eventually practically how can you use that in your setup? Where does it actually fit the bill? Is it for remote access reporting? Is it for a turnaround time that you're looking at? Or is it how are you going to make your life more efficient and productive with all the advantages that AI can give you today and aid you as a pathologist and definitely not replace you? And I like the part about where you said the hybrid pathology. I myself call it the augmented pathologist today. We're all augmented today with technology and digital and AI, and how seamlessly you can actually blend it into your practice. And what you said again, which is very right, is about the annotation. The data. It's very important that you get the right data to annotate in creating the models so that you come out successfully with a good amount of sensitivity and specificity and all of that, right? And efficiency of the model. That again depends on the kind of data you use in training, because that will reflect in the final AI output that you receive after application of those models on whatever your testing set is, right? And that's very important again. So it's important that pathologists in today's generation become very aware of the different processes of what it actually takes to bring out a solution finally in our practice. It's created by the pathologists themselves with the help of obviously data scientists and engineers who equally work with a lot of effort in bringing that into a productive kind of a product that we can finally use in our own practice. And I think the way you connected the dots was very beautiful as well, and pictorial illustrations that you gave. So let's move on to the audience to see if there is any kind of question. I'm sure Dr. Mayank would be very happy to take that. In fact, Dr. Badrinath already made a couple of comments on the pre-analyticals after what you had explained on that, right? So is it possible to set up a pipeline with additional biomarkers included to classify suspected blasts? And training data will be tough. However, it would make the models more robust. Dr. Mayank, would you have some perspective to throw on that? Will it be possible, do you think, in the future to adapt some pipelines parallelly as biomarkers also in determining and classifying blasts in the future? Do you think AI can go that far?
Ma'am, I think AI has already started going that far. So I tend to read that what is upcoming now. So multiple uh, chat bots specific to pathology have already been created. So one of them I just came across a few months ago is something called Path Chat. It is such a beautiful model they have created. They have not opened it for commercial use. It's just under research now and might come in the next few months. So what they are doing is you give that bot, the chat, complete clinical details of what the case is, what is the imaging, what were the findings in maybe flow cytometry, what were the findings in maybe some genetic studies, some fish analysis, or some NGS sequencing that you could do. And then you give the whole slide image and ask the bot to do a whole analysis of the entire data that you have given and then come to a conclusion.
Right.
Now, this is very, it is scary to be so close to how humans think. So this is how we think. We take in all the clinical details, we understand what the investigations are, then we see the slide and come to a conclusion. So it is definitely possible to have such pipelines where the entire data can be uh, where the entire data comes together, then the image is analyzed and a final diagnosis is given. People have started doing it, and we as pathologists in India need to understand that we need to create our own biobanks. A very important question that comes, a very important point that comes here is, I probably missed in my presentation, is creation of biobanks. We need to create biobanks. Biobank is nothing but a slide with all the clinical details, with all the imaging, with any ancillary investigation that were done. Such maybe 5,000, 10,000 such cases of acute myeloid leukemia created at a central level. And anybody anywhere in the country, if wants to use this data set to create their own model, they can happily do, they can freely do. This way, we will be creating models that are extremely robust on the basis of the data that is present in the country in our using our own data, and will be able to analyze and perform much better than what they are already doing. So creation of biobanks is another important thing that we need to ponder upon and we need to start working on, because uh, different countries have already started doing it, have already created their biobanks, have already publicly made them available. So we need to start working on our own biobanks.
Yeah, that's a very important point that you definitely brought across, and I'm sure we'll get there soon as well. Is there any other question from the audience? Does anybody have anything to say about their own experience with digital, or is there something at all? This is the forum. Also, there is something in the chat box again. Thank you, Dr. Mike and Dr. Rain, for insightful and forward-looking. Thank you so much for that, Dr. Badrinath. Definitely a pleasure to have these kind of sessions here on our platform.
Yeah, I have a question. Can I
Hello,
ask Dr.
sir.
Mani?
Yes, Dr. Sangvi, welcome, and very happy to have you here. Please ask your question. Yes.
Yeah, Dr. Mayank, thank you for that wonderful presentation. And
Thank you so much.
see, I've been a part of this digitization of pathologies for almost about more than a year now, close to 2 years. One thing I want to understand is how do you train uh, your digital AI that you are using? Means what during the course of your talk, I understood that the data scientists need to train the model. So how do you
Yes.
train the model? So is your instrument amenable to the training, or the data that you generate goes to the data scientists? Can you do it at your end, or it is going to the scientists or the data scientists end?
So, in my particular institute, sir, we are doing it on our own, sir. So, I have a faculty member who is uh, into artificial intelligence in pathology for the last 12 years now, sir. I think he's one of the pioneers in the country to get into it. He is also a coder. He understands Python inside out. So, we do all our projects under him. So we do the data annotations on our own. We do the model training on our own, the validations on our own. And the data remains with us. Data scientists not usually get involved in most of our models that we have created, and we plan to do so in the coming years as well, because the way we understand these models, the way we understand what we want from these models, a data scientist or an engineer, they will face difficulty in doing so. So if we are able to annotate the data, train the models, and then finally get an output, I think that would be really, really good. And we need more and more pathologists who are conversant with actual creation of these models.
Okay. I'm sorry if I might have missed it, but which platform, which scanner are you using to scan your slides?
Sir, we in our institute have Optra Scan, the OS Ultra.
Okay. So this is like I'm a user of the SigTuple AI 100.
Yes, sir.
But this is something which I've heard for the first time. So is it an
Optra Scan,
Indian? Huh.
it's an Indian brand, sir. Optra Scan is an Indian brand. Set
Okay.
up, their head office is in Pune, so we use their scanner. So
All right.
ours being a government institute, we are limited in options of what we can use, and this is the scanner which presently we are using.
No, no, that's absolutely fine. The fact that you're training it itself speaks volumes that how much proactively you are looking forward to integrating the AI into your routine work. And
Absolutely.
this brings me to yet another point. Since you are using the data from in and around Pune,
Yes, sir.
AFSMC is in Pune, then
Yes, sir.
aren't you introducing a bias which is a population bias, whether you are training it for abnormal slides or normal individuals, but you are still introducing a population bias based on location or locality per se? Or do you
We are, sir.
source your
We
samples from throughout the country?
Sir, so 2 points. I completely agree. There is a population bias. Uh, Second point, which I would like to say here, the population bias in our case, especially in the case of armed forces, is very limited because we have representation from the entire country. So our patients are from the entire country. They might be staying in Pune, but the person might be belonging to Arunachal Pradesh or Rajasthan or Haryana. So, in that sense, the population bias gets reduced but is not completely removed. How can we tackle this population bias that we are facing? Creation of biobanks. We, the bigger institutes, the smaller institutes, have to come together, have to contribute to the biobanks that we create, and then these biobanks have to be used to create our AI models. Only then we can be absolutely sure that the models that we have trained has actually got a representation of the entire country, and the models that then will be the models that will be created then will be extremely robust in what they detect and how they detect.
Yeah, thank you. And
Thank you,
I
sir.
have one more last question before I sign off. How do you propose introducing a QC in AI? Because a
So
quality control check is mandatory at all levels of our procedures, be it staining, be it running samples on a coulter counter or anywhere.
yes, sir.
So how do you propose to introduce the QC concept into your AI? Do you say
So
that there are these see, one thing which comes to my mind is maybe you have a very set kind of a slide that will go around across the scanners throughout the country, so you produce the same kind of slide, or you have same one slide and that you use as a QC material. What are your thoughts on this?
sir, I feel that one option what you gave is actually what we can do. We can have a standard slide, just like we have the standards that we give for our external QC for CBC. We have those standards available from different central institutes, and we test our machine on the basis of that. Just like that, we can have some standard digital slides which can be used as QC, and we can compare that how well our slides, our whole slide images stand against it. But I feel that is a bit difficult to do and will not be actually actually useful on ground. So what we can do, what we are actually working on is creating AI models specifically for QC, training the AI model what a good stain intensity is, what good stain color is, what artifacts are, how a gauze piece, thread, or a cotton whisker looks like on a slide, and telling it that if anything of any of these materials is seen on a digital slide, the slide needs to be flagged and needs to be rejected as QC. So before the triage part, where I had introduced that the AI will triage my peripheral blood smears and make it available for my reporting. Before that, a step can be added where the model does the QC itself. The model tells that out of these 200 peripheral blood smears, these 10 do not meet the QC standards on the basis of the training that model has already received of what a good slide is. So that is one option. And the other option, definitely what you suggested, that we can have a standard slide which everybody has, and we can compare it with our own images, and then we can titrate our pre-analytical and analytical variables accordingly.
Thank you so much, Dr. Mayank.
Thank you, sir. Thank you.
Thank you, Dr. Sanghvi, and thank you, Dr. Mayank, for all the elaborate answers that you have given for all the questions that was asked in today's webinar. A floor is open again for anybody else who's interested to have any clarity or question or query. Please do come out and ask that right now. Well, it definitely was a very interactive session. And there's so much of thoughts, of confluence of thoughts that actually happened in this particular series today, in this session today. And thank you for being a wonderful audience, for taking your time out on a Friday evening to be here with us today. And thank you, Dr. Mayank, again for having such a diligent preparation, coming out with all the points that you mentioned today. Each and every slide was equally important. It delivered a homecoming message, take-home message, which was very clear and apt. And I think for all the young audience who have been there, it's an eye-opener to what depths one can actually go, whether it's practicing digital, adopting digital today, and a clarity in how to approach digital in our day-to-day lives. And that's something you brought it out with so much of passion. So we look forward to engage with you again and collaborate with you in the future. Thank you once again for being here in the session today. And thank you, all of you, for taking your time out again. On behalf of SigTuple, as you all know, SigTuple is a company which combines optics, robotics, as well as data science to bring pertinent solutions out there in pathology. Watch our space out on LinkedIn, where we will be coming up with more such interactive sessions, and also a lot of information regarding our products, which I think all of you will find useful in practice. Do reach out to me. You can reach out to Mr. Manohar Daka, who's there on the call today as well, if you have any queries. And we will also reach out to you for the prizes for the quiz session. And if there are any other feedbacks, you can always write to us in person as well. Thank you again, and wishing you all a great weekend ahead.